Mandy. Congratulations, miss. Okay. You got your notes over there? All right, here we go, guys. You guys ready? We're going to talk BC after this. Don't worry. All right, guys. Focus. So this is a pretty important topic. You're going to see right now why. So differential equations. There is a whole course dedicated to this after Cal 2, after multivariable calculus. At the university, it's Cal 1, Cal 2, Cal 3, if they offer a 3-sequence course. And then differential equations, DFQ. There's a whole course dedicated to this. You already know what a differential equation is for the most part. We've been doing the simple ones. We've been doing a first order equation, which is just one derivative, first derivative. If your university does not offer a 3 calculus course, it's going to be single variable cal, multivariable cal, and then differential equations. So there's a whole course dedicated to this. So that's how important it is. So here we go. These are the differential equations that we have been doing. And for these, they're pretty straightforward. You already know how to solve for that. So what does it say? Find all functions y that satisfy dy dx equals secant squared plus 2x plus 5. So let's see if we can do this together really quick. So I want a function y. So I'm going to write y equals. So all I'm doing, because this is my derivative, all I'm doing is taking a antiderivative. What is the antiderivative of secant squared? 10x. What's the antiderivative of 2x? X squared. Yeah, 2x squared divided by 2. The 2's cancel out. What's antiderivative of 5? 5x. And because plus, perfect. Plus c. Don't ever forget that. Plus c. And this, you already have experience with that. You've been doing that over and over again. So this is just like a warm-up. Are we cool with that? All right, so here's another warm-up. But notice this one, it says, find a particular solution to the equation dy dx equals blah, whose graph passes through the point 1, 0. That 1 is an x value. That 0 is a y value. So now I don't want a plus c. I want like the actual constant. Does that make sense? You're still going to put plus c when you're solving. So here we go. I'm going to write y equals, because all I'm doing is antiderivative, right? What's the antiderivative of e to the x? E to the x minus, what's the antiderivative of 6x squared? 3x to the, wait, not 3, 2. No, it's okay. 2x to the third. And in case you're wondering, like, Travis, how'd you do that? Add 1, divide by that number. And then we're still not done. Plus c. Are we okay? All right. Now from there, I need to solve for what c is. I take that point, 1, 0, and I plug it in. That 1's an x, that 0 is a y. Does that make sense to you guys? 0 equals e to the 1 minus 2 times 1 to the third plus c. So that means I have, let's see, 0. And you don't have to do it repetitive. I'm just showing all the details here. And I'm going to move these two to the left here. So I'm going to say that c equals 2 minus e. Do you guys see that? So my equation, and I'm going to write, so my specific equation or particular solution is y equals e to the x minus 2x cubed plus 2 minus e. If you want to group the 2 and the e together with parentheses, you can if you want, but you don't have to. They're constants. What's up? When I move e minus 2, oops, my bad. That's no, wait, no, that's 2 plus 2 minus e. Okay, what? Yeah, when I move to the other side. I'm using the reflective property from geometry. I guess I should have done this first. I should have done 2 minus e equals c, and then I can just rewrite it as c equals 2 minus e. So sorry, guys. What's up? Find the exact equation. Because they wrote particular solution, we can actually leave it as in e to the x plus 2x cubed plus y equals negative e if I wanted to. But usually they tell you y equals f of x, or find like it in terms of something. And you'll see right now in a little bit. How do we feel, guys? Do we feel okay? Okay. Do you guys want to read this really quick to yourselves, really fast? Okay, all that means is that you can group the x's with the x's, the y's with the y's. Now, I probably should have put in there for good notes, not all differential equations are separable. So let me write that in here. Not all diff EQ are separable. That's how you abbreviate differential equations, diff EQ. But the ones that I show here, because we're rookies, these are. Eventually, we're going to get you to where we're going to ask ourselves, is this separable? Can I? Blah, blah, blah. But right now, we're just practicing. Cool? So check it out. The very first one, example 3. Solve for y if dy dx equals xy squared and y equals 1 and x equals 1. So they want an equation. They want y equals something. Notice, how is this different than the last one? I can't just do an antiderivative because this has a y in it. That makes sense? Like this was take the derivative with respect to x. Well, now there's x's and y's. So yeah, it's like implicit kind of. So we got to separate stuff. We got to group them all together. So here we go. Here's how we're going to do it. First, we just do basic algebra. Laws of exponents, x squared, y squared. Can we do that? Okay. Next, I'm going to group the y's with the y's, the x's with the x's. Chavez, what does that mean? That means this. I'm going to write dy over y squared. See, divide by y squared equals, and I'm going to multiply by dx. So times dx times dx, so I'm going to have x squared dx. How do we feel? So cautious, guys, a word of advice. Do not put the dx in the front. I know what you mean, like you're saying dx times x squared, but do not put it in the front because how are we going to get rid of the dx and the dy? We're going to integrate. And remember when you draw the integral symbol, the elongated s, the dx means like this is the end of your integrand. Cool? Okay, so I'm going to rewrite this. Here's how I'm going to rewrite it. 1 over y squared dy equals x squared dx. So just like I said right now, what am I going to put in front of this? An integrand symbol. Why am I doing that? So I can get rid of the dy and dx. Does that make sense to everyone? All right, so you're one more step of calculus, and it's not really calculus now. Integral y to the negative 2 dy. I'm just making it simple. Making it where I can take an antiderivative. Does that make sense? All right, what's antiderivative of y to the negative 2? Not everyone at the same time. Yeah, y to the negative 1 over negative 1. So can I put the negative in the front? And I could put plus c. Okay, so drop your pencils down. Don't write this part down because I want you guys to listen. I could put plus c if I wanted to. I'm going to call that c1 equals, and don't write down, don't worry, I'll tell you what to write down in a little bit. What's the antiderivative of x squared? X cubed over 3, and then I could put plus c2, or c2 here. But when I do this, whenever I subtract c1 and I subtract c1, isn't c2 minus c1 still a constant? Okay, so the common practice is to not write c on the left-hand side with the y's, and to just write 1c with the x's. Does that make sense to you guys? Okay, so now you can write. You can put in their common practice, just put one constant. Oh, ask BC, what's up? So Chavez, how are we going to find the constant? We're going to let the situation tell us what that constant is. Does that make sense? We're going to let this situation, you see how it says x equals 1, y equals 1? That situation will tell us what the constant is. Cool? All right, this looks like a good place to type in my 1, 1. That is my quarter pair 1, 1, right? So I'm going to rewrite it, guys. Negative 1 over y equals x cubed over 3 plus c. This looks like a good location to solve for c. So I'm going to put insert x equals 1, y equals 1 for good notes. So here we go. 1 divided by, well, negative 1 divided by 1 is going to be negative 1 equals 1 to the third power is 1. So I'm going to have 1 over 3 plus c like that, right? Okay. Now how do I get c by itself? Subtract 1/3. So I'm going to write an arrow. I'm going to put c equals, what is negative 1 minus 1/3? Perfect. So negative 4/3. I wrote an arrow because I'm running out of space here. So now that I know that C is negative 4/3, that's what I'm going to substitute for my C at this step. Does that make sense, guys? So I'm going to write it like this. I guess I could write it the one below. Negative 1 over y equals, yeah, I'm going to do that one. X cubed over 3 minus 4 over 3. Oh, look, they're being nice to me. And I should have written smaller. I see that my denominators are 3. You're done with calculus. Everything else is algebra. You're trying to get this in terms of y equals. Does that make sense? Yeah, we're not doing calculus anymore, guys. We're just doing algebra. So I'm going to write negative 1 over y equals x cubed minus 4 over 3. Do you guys know a hack of what you would... Yeah, see how... Okay, so I'm going to slow down because this is probably some algebra stuff that, you know, we haven't had algebra in the last 2 years, like hardcore. This is a fraction. This is a fraction. So side note, if I have A over B equals C over D, isn't that the same as saying B over A equals D over C? Yeah, it's the same. As long as you keep everything together like that. Does that make sense? So this is negative y over 1 equals 3 over x cubed minus 4. Does that make sense to you guys? Okay, that's just algebra, guys. So that's stuff that we should have done like a long time ago. If you didn't, it's okay. You know, blame it on the situation we're in. Are we cool? All right, we just got to do one little thing. So I'm going to write it on top of here. I ran out of space. I'm sorry, guys. So I'm going to write it negative y over 1. Well, you know what? I'm going to remove that 1 there. Equals 3 over x cubed minus 4. All I got to do is, I want a positive y. So all I got to do is what? Yeah, either divide by negative 1 or multiply by negative 1. It doesn't matter. Y equals, negative in the front, 3 over x cubed minus 4. And I had a professor who would always, all the time, tell me to put a minus, my minus there. Because I had a habit of doing this. I would just put it here. It doesn't matter, guys. You can put the negative with the 3 there, but because he told me, I'll go ahead and do that. How do we feel? That's it. We're done. That's what they wanted, right? So you can see there's a lot of algebra. There's not much calculus. The only calculus is doing the antiderivative. The rest is algebra. Okay. So you can tell what's going to happen, guys. Tomorrow we're going to do even more algebra with logs and exponentials. So you guys remember, right? Like when we did the dy. Okay, yeah, it's going to be fun. It's going to be fun. Now, if you're weak with logs and exponentials, then you might not have a good time initially, but you see that it's not going to be that bad. All right. Use integration to find the general solution to these equations. So now we're just practicing. I don't see any y's over here. So in my opinion, I would just do this. dy dx equals 4x squared minus 4x. And I'm just going to do an antiderivative of that. So I don't need to separate my variables. This is coming from UH, guys. So you can already tell what's going to be the next quiz. So I'm going to write y equals, what am I going to write? 4x cubed over 3 minus, which is, and then am I done? Plus c. Let's look for that answer. Is that in there? It's the first one. Does everyone see how we did it? Okay. Let's look at the next one. Does the next one have y's in it, x and y's? We're going to have to separate our variables. Cool? Okay. So, I want the y's with the y's. You cannot separate that 5. That 5 is grouped with that y, guys. Because isn't the y plus 5 in the denominator? So, how do I get rid of the y plus 5? Multiply. When I do that, you're going to have y plus 5 dy equals x minus 3. If you want to put this in parentheses, dx. Now, I will give you a heads up. Personally, I don't like it, but textbooks have done it. I do not like when they remove the parentheses and they do that. I don't like it because it looks like it's, right, you see it, but it's understood. Don't get mad. It's understood in the math world. We understand it that it's that. times dy, that it's this times dx. Cool or not cool? Okay. Is everyone okay so far? Nothing crazy has happened, right? All right, what's antiderivative of y? Y squared over 2. Yeah, that's it. What's antiderivative of 5 with respect to y? 5y. Chavez, why? Because this is my integral with the y's on it. Are we okay? Don't write a plus c on this side. Write the plus c with the x's. What's the antiderivative of x? Minus what's antiderivative of 3? What am I going to write? Plus c. Before you continue, I'll wait for everyone to catch up. Before you continue, let's be smart, guys. You're done with calculus. You're done. Everything else is algebra now. Notice your answer choices. Do any of them have fractions? No. What's up? Did I mess up? Oh, sorry. So I see a 2 in the bottom. I can multiply the whole shebang, all of it, by 2, and that will cancel my denominator in the bottom. Does that make sense to everyone? All right, so let me see. I'm going to have y squared plus 10y equals x squared minus 6x. Oh, here's a good question. Plus, do I write 2c or do I write c? C. Perfect. Why am I writing c? It's still a constant. Any constant times 2 is it still a constant? It's still a constant. So you're just going to write c. Do not write 2c. Do we understand that? Okay, we're done, guys. Now you just got to make it look like one of these. Notice that all of them have equal c. So that means move the x squared to the left. Move the negative 6x to the left. So my equation is going to be, is that a negative x squared? Negative x squared plus y squared. And then what do they put next? That's 6x plus 6x plus 10y. That's a 10. Equals c. Let's look for that. Is that in there? Which one is it? C. All right. How do we feel? All right. Let's keep going. Let's keep going. We're getting more experience. This is good. So again, they want the same thing, guys. This equation's here. It's in terms of x and y. I'm going to separate my variables. You must separate. Please show that. So what does that mean? It just means group the y's with the y's, group the x's with the x's. Cool? So I'm going to go dy over, what did I put in the bottom here? Secant y, perfect. Secant y equals, and what did I put here on the right-hand side? Yeah, you can write dx over x minus 3. I'm going to write it as 1 over x minus 3 squared times dx. You can write dx over x minus 3 squared, but I'm going to just writing it like that for simplicity. How do we feel? Okay. Okay, so here's what I see. I see the left-hand side is going to be pretty simple. The right side can be complicated. It depends. All right. So what's, I'm not going to integrate right now. What's 1 over secant? Bless you. Cosine, yeah. Yeah, be confident, guys. You're good. So can I write the left-hand side as cosine y dy? Yes. Now, side note, you don't have to. If you're confident, I think you're fine. But if you feel that you're not confident, you can do u sub with the right-hand side. Like, oh, child, I don't know if I can integrate that. Because, right, we want to integrate that. So integral cosine y dy equals, if you're not confident, you can do u sub. What would I make u? X minus 3, perfect. What is du? 1 dx. There's 1 du. There's a dx there. I can just replace it. So this is the same thing as 1 over u squared du. Does that make sense to you guys? And if you rewrite it again, u to the negative 2 du. How do we feel? Yeah. So, well, I would write that on the side. I would leave this as... Personally, I would leave this as this, but I'm confident. If you're not confident, just put it on the side somewhere. Okay, so here we go. What's antiderivative of cosine y dy? What's antiderivative of cosine? Sine. Positive or negative? Yeah, positive. Equals, what's antiderivative of u to the negative 2? U to the negative 1 divided by negative 1. So can I say negative 1 over u, and isn't u x minus 3? Can I say that? Plus, don't forget, plus what? Plus c. Let's look for that. Is that in here? Yes. How do we feel? All right, BC, if you want to get started with the question in advance, the next one, or I think the next two are going to be too simple for you guys. So if you guys want to get started with the free response, you can, and then we'll check it right now. All right, question 7. If you want to continue, that's fine. Continue with them. Ready for you guys? We're still with this. We're just practicing, guys. Ready? I have x's and y's. I got to separate it. Here's how you're going to see it in Delta Math today. So I'm going to, what do I do with that 3y there? Perfect. So I'm going to write 3y dy equals x squared plus 1. If you want to put parentheses, I would. Dx. You don't have to if you don't want to. Then I'm going to, well, I'm not putting plus c yet. I have to what? Put the integral symbol. So what's the antiderivative of 3y? Perfect. Equals, what's the antiderivative of x squared? Plus, what's the antiderivative of 1? X plus c. It tells me this question said that I want a particular solution, so that means y equals something. They tell me this. So that means when x is 3, the y value is negative 2. Notice they word the word initial. Usually initial is like, well, it doesn't matter. Okay, so here we go. Let's plug in. Cool. So we're going to go, should I plug in now? Yeah, that's fine. 3 times negative 2 squared divided by 2 equals 3 cubed over 3 plus 3 plus c. I don't think we need a calculator, but let's see. Negative 2 squared is 4. Positive 4. 4 times 3 is 12. 12 divided by 2 is, so 6 equals 3 cubed, or I guess it's going to be 3 squared, so 9. Right? 3 to the third power is 27 divided by 3, 9. 9 plus 3 plus c. Move the 9 and 3 to the other side, or I guess 9 plus 3 first is what, 12? 6 minus 12. So c equals positive or negative? Negative, right? So I'm going to come back here and I'm going to plug it in. So I had 3y squared over 2 equals x cubed over 3 plus x minus 6. All right. Next, you're trying to get y by itself, correct? So I'm going to multiply the whole shebang by the reciprocal of 3 over 2 times y. So I can get rid of the 3/2. So I'm going to multiply by 2/3. Does that make sense to everyone? So when I do that, I'm going to have y squared equals, let's see, 2x cubed over 9 plus 2/3 x minus, 3 goes into 6 twice, 2 times 2, 4. And check my math, because sometimes I make mistakes. We're just doing algebra. We're not doing calculus anymore. And then one last step. How do I get rid of that square there? Square root. When you take square root, don't forget the plus minus. Y equals plus minus square root of all this shebang. Now it can't be, right now I have 2 equations, the plus and the minus. I need to only have one. Is it the positive square root or is it the negative square root? Why is it the negative? Yeah, when I plug in a 3, you're supposed to get a negative 2 as an output. Does that make sense? When I plug in an x value of 3, I need to have a negative 2 as an output. Yeah, don't worry, we're going to explain it. We're going to explain it. Check. What am I checking? If I plug in a 3 into my x value, do I get an output of negative 2? So let's see. 3 cubed is 27. I see that 9 down here. 9 goes into 27 3 times. 3 times 2 is 6. So this gives me a 6. And then I'm plugging in a 3, right? So the 3's cancel out. So 6 plus 2. 6 plus 2 is 6, 7, 8. Is 8. 8 minus 4 is 4. What's the square root of 4? 2. And do I have a negative on the outside to make a negative? There it is. How do you feel? Parker, did we get that?
Once you explain it, yeah, but it's just like,
Yeah, a lot of students mess up with the plus minus. I'll show you for your response that a lot of students, and I think I graded that one, where they just forgot the negative and I mean, luckily for us, usually this equation is worth just 1 point, usually. But the process is worth like 5. Someone had a question? I heard someone say Chavez. Okay, let's go to the next one, guys. Example 8. Given the differential equation, dy dx equals x squared over 2y squared, find a particular solution, y equals f of x with the initial condition, f of 3 equals negative 3. All right, I'm going to write smaller just in case I take up more space well, it doesn't matter. All right, here we go. First thing, move the x's with the x's, move the y's with the y's. So we're going to have 2y squared equals x squared dx. Can we at least do that? If you do that, that's probably a point. Next, we're going to what? Integrate. Put that integral symbol. What's the antiderivative of 2y squared? Yeah, 2y to the 3, or 2/3. You can write 2/3. I'm just trying to... Yes. Oh, man. That's why you guys were looking at me weird. You must put the dy because it was there to begin with. Yeah, I'm sorry. Yeah, you got to tell me. I make mistakes, guys. That dy must be there. If it's not there, you're not going to get the point. That dy must be there. So 2/3 y cubed equals, I think we did that correct, equals, what's the antiderivative of x squared? X cubed over 3. Did we do that correct? And then I put plus what? Plus c. I think this is a good place to plug in my point. The point they give me is 3, negative 3. I would be careful. You can do it that way too. But I would be careful because if you solve for y, it's going to be a cubic. And I see like something plus c over like 2 or whatever. Yeah, because that's a 2 there. And then that looks like, oh, now let's plug in the 3 and the negative 3. And now you're going to have to get c by itself again. You know what I mean? Like the whole point is to get c by itself. And right now, c is by itself. I just got to, does that make sense? But yes, you should still get the same answer. All right, here we go. I'm going to plug in that 3, negative 3. If you want to make life easier, maybe multiply by 3, and then maybe you could do it in one more step, and then, you know what I mean? But it doesn't matter. I already said I want to do it here. I'm already committed, so I'm going to do it right here, guys. 2 times 3, is it a positive or negative? Negative, right? Negative 3 to the third divided by 3 equals, make sure we don't have any mistakes here, 3 to the third over 3 plus c. All right. Negative 3 to the third is negative 27, but then I have a 3 in the bottom, so that's negative 9. Negative 9 times 2. Okay. And then this is going to be 3 to the third again, 27 divided by 3. That's going to be a 9, correct? Plus c. So that means c equals, so negative 18 minus 9, is that a negative 27? Okay, so I'm going to plug that in right there. So I have 2/3 y cubed equals x over 3. I said 2/3. I could write 1/3 x cubed, but that's fine. Minus 27. So I'm going to, what am I trying to solve for? For y? Okay. Multiply by what? 3 halves, the reciprocal. So times 3 halves, and then times 3 halves. And there it is, my colored pencil, so you could see the notes here. Y cubed equals, let's see, the 3's cancel out. So I have x cubed over 2 minus 27 times 3, 30, 60, 90, 3, 6, 81. 81 over 2. Okay, I'm going to, yeah, that feels correct to me. I'm going to write it with the 2 in the bottom, guys. I should have just done this. That's fine. And then all I'm going to do now is just take the, how do I get rid of that cube there? Cube root. When you do cube root, make sure you put that 3 there, or else it's a square root. So y equals the cube root of x cubed minus 81 divided by 2. And I'm going to check it. No, that's only for square root. Cube root does not have plus minus. Yes. Even powers, yeah. Even root. All right, check it. Don't just say I'm done. We're good. We got it. Check it, guys. So what was my x value here? 3. If you plug in a 3, do you get a negative 27 inside that cube root? Because the cube root of negative 27 is negative 3, right? So let's see if we get that. 3 cubed, that's 27, minus 81, negative 54, divided by, negative 27. There it is. We got it right, guys. 27 minus 81, it's a negative 54. And then half of 54 is 27, so negative 27. The cube root of negative 27, negative 3. So it works. Cool or not cool? Okay, here we go. Ready? Go to the next page. Our first free response. Well, we've done many free responses, but. All right, I want everyone to have the experience. Are you guys ready? Do you guys want to see if you can figure out letter A? Letter A is not okay, in case you're wondering, this is the part that we just learned today. Learned today. This you already know. This you already know. And I know you haven't even read the question yet, so you're like, Do you guys want 2 minutes to read the story and then give you another 2 minutes to see if you can figure out letter A? Just focus on letter A. So take 4 minutes, focus on letter A. Don't worry, YouTube, I'll fast forward this. Yeah, go for it.
Yeah, we're required. Yeah, because if we left with 6 periods, they hear right now, right?
There, miss. What's up, miss?
You have Delta on, right?
All right, guys. Did you guys read the situation of what's going on? All right. So hopefully everyone read this. YouTube, I hope you read it. If you didn't, pause it and read it real quick. They don't have to give you the volume formula. They did. They were nice. And they told us DHDT, how DHDT behaves. They computed it for us. That's fine. Are we okay? They want to know, let's see what letter A says. Find the rate of change of volume of the water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. Bless you. What does that mean, rate of change of volume? What do they want? Perfect. If you understand that that means dVdt, you're winning. They give you the volume formula. You don't have to do product rule if you see it. You can if you want. What's a constant? Let's talk about this cylinder here. The radius is a constant. It is always 1. You can do product rule if you want. And then when you plug in your drdt, dRdt is always going to be 0. And so that's going to go away anyways. I would not do product rule. I would hope that you know that your R is always 1. So your dRdt is 0. Sorry. I didn't mean to write that down. Does that make sense to you guys? All right. So here we go. I'm going to write volume, pi r squared h, and then tell me what is a constant on the pi r squared h. Yeah, perfect. The pi r squared is a constant. So look how easy it is. This is probably a point. I haven't looked at the rubric just yet. All I'm going to do is take a derivative of this with respect to what? So dv dt is equal to pi r squared, and then what's the derivative of h with respect to time? There it is. You got it. That's my volume formula. What's up? Why do I what? Oh, yeah, I'm going to substitute that right now. What would it be 0? The derivative of pi r squared is 0, but I'm not taking the derivative of pi r squared. I'm taking the derivative of pi r squared h. It's like saying, so don't write this down, just listen. It's like saying, what's the derivative of 5x? You're not going to tell me 0, because 5 is a constant. You just tell me 5. You can do product rule with 5x if you wanted to. Y prime equals first, 5 times derivative of the second, 1, plus second x times derivative of the 5, 0. Oh, look, you just get 5, because that goes away. Do you see that or no? Yeah, so, and I know I'm using a very basic sample, a very simple one. You know what, maybe I should have used the trig one, because it's better. It's like saying y equals 3 sine x. You know what I mean? Like, okay, what's up, Parker?
The R would become 2R.
You can. If you were to do product rule and you want, I mean, the R is not changing. The R is constant.
Yes, okay.
But if you did it, 2R dRdt, and what's dRdt? 0. So if you were to plug in at the very end, you're still going to get your same answer. But the best way on this one is to do it like this. Because R is a constant. Yeah. All right. Now let's find out what dv dt is, guys. So I'm going to write dv dt is equal to pi times, what's my radius? 1 squared times dh dt. So I'm going to write times negative 1/10. And then the square root of, what's my h? 4. So here it is. I'm going to get pi times 1 times negative 2/10. So all that reduces to negative pi over 5. And I need units. Negative pi over 5 cubic feet. Cubic feet per second. You need units. It tells you right here, indicate units of measure. Are we okay with that, guys? So how do you feel? You think you can do that? Well, with experience, you will, right? Okay. Do you guys want to see if you guys can tackle letter B? So take a 2-minute head start. It's a play on words, guys. So think about it carefully. Yeah, that's a 3. Cubic feet. Let me make it better. What do you guys think? What do they want? It says when the height of the water is 3 feet, I'm going to underline this, is, and I'm going to underline, well, I'm going to put it in a bracket, is the rate of change of the height of the water with respect to time. I'm going to put that in bracket. Put all that in brackets. So, yeah, perfect. So the rate of change of height of the water with respect to time. What is that? You said it right now. What is that?
Oh,
That is dHdt. So let's reread it again. Delete all that. Well, don't delete it, but pretend that it's not there, the bracket, and replace it with dHdt. So when the height of the water is 3 feet, is dHdt increasing or decreasing? So how do I figure out if dHdt is increasing or decreasing? Take a derivative of dHdt. So it's going to be the second derivative. And if the second derivative is positive, then dHdt is. And if the second derivative is negative, then dHdt is. There it is. Do you guys see that? Perfect. So here we go. Ready? I'm going to first write what dHdt is. They gave it to me. What was dHdt? Okay, so 1/10 square root of h. I'm going to rewrite it. Negative 1/10 h to the half. Here I am. I'm about to take the second derivative. d2h over dt squared. That means second derivative is equal to, so what is negative 1/10 times a half? Negative 1/20th, and then I'm going to subtract 1 from the half, so h to the negative half. And did I take this derivative with respect to h or respect to t? With respect to t, so right next to it I got to write what? Perfect. That is my second derivative right there. So let's see if I can rewrite it pretty now. D squared h over dt squared equals negative 1 over 20 square root of h times, what was dHdt? Negative 1/10 square root of h. Ooh, I see a lot of stuff canceling. Let's evaluate. You guys ready? They did tell us that the water is 3 feet, but I don't even think I'm going to need it. Do the square root of h's cancel out? They do, guys. I don't even need it. So what is negative 1/20th times negative 1/10? It's going to be a positive 1 over, what's 20 times 10? 200. Is that a positive number? Yeah. So I'm going to write right here what's happening. I'm going to write it. I'm going to use their language. I'm going to write the rate of change. I think you would still be okay if you write dHdt, but I'm going to write there. I'm going to use their language. The rate of change of the height of the water with respect to time is what? Yeah, I heard, be confident. Is what? Is increasing. Why? What's positive? The second derivative, so make sure you say that. With respect to time is increasing since the second derivative, I'm going to write it like this, guys, with this symbol. Since d2h over dt squared is positive at, give me a specific time, at, well, not time, when the height is what? At h equals 3. Perfect. Feet. That's full credit. The rate of change of the height of the water with respect to time is increasing since the second derivative is positive when h is 3 feet. How do we feel? You didn't like it at all? All right, tell me where you're confused. Because they wanted to know if dHdt was increasing or decreasing. So look, okay, throw it away. How do I know if f is increasing or decreasing? Yeah, I'm not in this problem anymore. I'm just asking a general question. How do I know if I have a function called f, how do I know if f is increasing? Yeah, if the derivative is positive, f is going up, right? If the derivative is negative, f is going down? Do you agree? F is decreasing? Okay, now let's go to this story. How do I know when dHdt is increasing? When the derivative of dHdt is positive. Well, what's the derivative of dHdt? The second derivative, d squared h over dt squared. Does that make sense? So where is dHdt increasing? When the second derivative is positive. Where is dHdt decreasing? Where the second derivative is negative. Cool?
Okay. Well, like, looking at the question, I would have not thought to do that because, like, how would you know, like, oh,
No, well, that's why it's a play on words. You got to read it carefully. Look, see how I put a bracket, the rate of change of the height of the water with respect to time, and then I ended the bracket? All that in blue is dHdt. Like you should know, like that we should know. So then you can just say, okay, pretend that literature is not there, and let's fill it in with dHdt. And then you read it again. When the height of the water is 3 feet, is dHdt increasing or decreasing? Oh, they want to know where dHdt is going up, or is it increasing or is it decreasing? That makes sense? Yeah. So you just, like, you put that in bracket and you're like, oh, and then you just delete it. Pretend you delete it. And then like, all that means dHdt, and then you read it. When the height of the water is 3 feet, is dHdt increasing or decreasing? Oh, okay. I need to figure out the derivative of that one. Cool? Any other questions, guys? Ask. dHdt is negative.
What is that?
Oh, it just means that my height of a water is, the water height is going down, but it's decreasing at an increasing rate. Yeah, don't worry. Yeah, then, well, it would have been easier if it would have been increasing. Like, okay, increasing at an increasing rate, increasing at a decreasing rate. I think it's always easier to look at that. Do we know what both of those mean? So it just means like something, you know what, I actually saw a Facebook article about this exact, for the ocean, something increasing at a decreasing rate. So when I say something is increasing at an increasing rate, I mean that I'm like exploding. When I say something is increasing at a decreasing rate, it's growing, but not fast, not as fast. I'm trying to look for a marker here. It's kind of similar to your concavity thing. Okay, I'm not in this situation because this one, the dHdt was negative. Increasing at an increasing rate. So this is my original, and I know it's hard to see. That's increasing at an increasing rate. All my slopes, they're getting faster and faster. Increasing at a decreasing rate looks like this. I'm still increasing, but it's slowing down. The rate of change is slowing. That makes sense? So that's what they're, kind of trying to say here. So if you're trying to see like, well, what does it mean? Because you're like, what does that mean? That's... Yeah, well, dHdt is negative, but they don't want to know. They want to know, is dHdt increasing or decreasing? So they want to know, like, oh, it's positive, so you're decreasing it. Okay, all right, here we go. Yeah. Oh, because I took the derivative with respect to time. The derivative of h with respect to time is dHdt. If I would have taken the derivative of h with respect to h, then I would have left it alone, and I would not have a dHdt here. But I didn't take the derivative of h with respect to h. I took it with respect to time. That makes sense? That's going to come in super handy when you take multivariable calculus at MIT. All right, here we go. Last one. At time t equals 0, and I know that I just put you guys on the spot. The height of the water is 5 feet. Use separation of variables to find an expression of h in terms of t. Do you guys want to lead me on this one? So they want, what do they want? An expression of h in terms of t. They want h of t, right? Okay, so tell me, what do they give me? What was dHdt? Okay, what's the first step? Move the h's with the h's, move the t's with the t's. There is no t. Well, you're going to leave the constant there then. So how do I get rid of that square root of h to go to the left? Divide. So dh over square root of h equals negative 1/10 dt. Can everyone do that? I'm going to rewrite it so it's simpler. Here we go. I'm rewriting it, guys. I haven't taken the integral yet. I'm going to write h to the negative half dh equals negative 1/10 dt. Are we still okay? Now I'm going to what? Integrate. So here we go. I'm going to have, so h to the negative half, add 1, divide by that number. So negative half plus 1 is a half, and then when I divide by half, that's the same thing as multiplying by 2. So there it is, 2h to the half equals what? Negative, and then what letter do I use? t. And then I put, what do I put? Plus c. Can everyone get to there? All right, next. Do they tell me, look what they tell me, at t equals 0, how much water do I have? Yes. Yes, I just did my power rule, or the opposite of power rule. So that negative half, I added 1. So that's where I got a half. And then I divided by a half, which is the same thing as multiplying by 2. Okay. Are we still okay, guys? All right, here we go. I know this much. When h is 0, water is 5. When h is 0. When time is 0, water is 5. So h is 5. So that's what I'm going to plug in. Are we okay? So I'm going to go 2 square root of 5. Does everyone okay with why I wrote square root there? H to the half is square root, right? Okay, you know what? Let me rewrite it. 2 square root of h equals negative 1/10 t plus c. Okay, now we're good. 2 square root of 5 equals negative 1/10 times 0 plus c. So what does that tell me about c? C is 2 square root of 5. All right, so here we go. I'm going to rewrite it. 2 square root of h equals negative 1/10 t plus 2 square root of 5. All right, what am I trying to solve for? H. So how do I get rid of the 2? Divide by 2, divide by 2, divide by 2. So now I have this. I have square root of h equals negative 1/20th, just put the 2 next to the 10. 1/20th t plus square root of 5. Now how do I get rid of the square root? Squared. 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 Oh, man. Squared. Let me zoom in on that. There we go. So here's my equation. H equals, and I'm not going to expand it, leave it alone. This is your answer. It's going to probably, all of them are, the rubric's probably going to have this answer because it's the simplest one. And if you want to write h of t, go ahead, but you don't have to. I think they would still give you the credit even if you just wrote h. How do we feel? Well, we know it's a function of t, but you could have just written, if you just did that, you're fine. Oh, well, this is simplified. I mean, you could expand it, but this is this is the best. You know what I mean? That's my equation. That's what they wanted right here. No, you don't. You can just write h equals. Should we look at the rubric? Look at the rubric. I was looking at it earlier, but I didn't look at it good enough. All right, let's see. Number 4, letter A. Yeah, I think we did it exactly the way they did it. They put the fancy little line with the h equals 4 in the bottom. That just means evaluated at. How many points was letter A? 2. Look, they give you 1 point for the unit. So even if you didn't know how to do the derivative, if you know, it's cubic feet per minute, cubic feet per second. If you wrote cubic feet per second, they probably, maybe, I don't know, but it says there 1 point for the answer. I wasn't there to grade this one, so I don't know if it's a condition or not. Sometimes it is. Letter B, how many points? Did we get it right? 1/200, because the second derivative is positive. For h greater the rate of change, the height of the increase in the water is 3 feet. Yep, perfect. We got it. All 3 points. Letter C. Notice that they give you a point for separating them. So that means the h's with the h's, the t's with the t's. You see that top line, that first line? That's 1 point. Isn't that cool? Antiderivative. If you take the antiderivative correctly, that's 1 point. Let's see, constant of integration and uses initial condition. That means the c and using the 0 and the square root of 5. That's another point. And check it out. let's say you didn't know how to get H of t. Relax. H of t is only worth 1 point. So all the work leading to H of t, maybe you thought, man, I don't know if I can do that. Well, it's only worth 1 point. So if you get 8 out of the 9, you're probably in pretty good shape. Did we get their equation? Yeah. Notice the little note. What does it say? You guys want to read it out loud? Look at the both notes. Look at the top note. How many points out of 4 if you don't separate? 0. That's because a lot of kids are doing the antiderivative immediately because they can see it. Don't blame them. Their teacher hasn't told them. They can see it and they're smart enough. Like, oh yeah. So they go right from the equation, from the first line here, right to this, because they can see it. They're like, oh yeah, antiderivative and blah blah blah. But because their teacher didn't tell them, like, hey, that's a point. 0 points if you don't separate. Cool or not cool? So how do you feel? Okay, so don't worry. We're going to start off simple. You have a delta math. We're not going to give you word problems just yet. All you're doing is practicing doing antiderivative and getting your initial condition. Separating your variables. Does that make sense, guys? So we'll finish the rest tomorrow. Make sure you practice. So let's do our delta math, guys.